Hello. In this clip, we will learn about Process Capability Index. Let's first understand what is it good for. Process Capability Index will help you to answer these three questions: whether a process is capable of meeting customer needs, whether a process is within customer specification limit, and then whether a process is centered. All these three questions are very important for a process owner to answer. So let's go through this and see how we can answer these questions. So to start with, we will get familiar with some of these equations here. These equations would be helpful us to actually answer the questions that we raised in the very first line. Now, you can see the first thing that we try to calculate here is what we call CP. Okay, this is the CP formula. You can use any of the equations. It's nothing but the ratio between a process width and a customer specification width. This ratio will help you to understand whether the process is capable of meeting the customer needs. If the process width is within the customer specification limit, that's what we call tolerance, then we can say that the process is capable of meeting customer needs. But it doesn't actually tell you whether the process is within customer specification limit, though. So for that, we will use these equations, CPK, which will actually let us know whether the process is within customer specification limit. Okay. Uh, so this is more important than just a basic CP. CP is just telling me whether the process is capable, whereas CPK is telling us whether the process is within customer specification limit. And then we will also see how to come up the answer whether the process is centered or not in a few minutes. Now you can see this is just a diagram to give you an idea of what we are discussing here. Let's say this is customer specification limit. Say customer wants the product to be delivered between 3 to 8 days, and your process is capable of making the delivery within 2 to 6 days. Is it meeting customers' needs? Yes, it is. Since the process width here, the upper control limit and the lower control limit within the upper specification limit and lower specification limit of the customers. So in this case, we can conclude that the process is not only capable, but process is within also the customer specification limit. Now let's go through the first example here, the only example that we'll cover actually. So let's go through this. A manufacturing plant has recently received an order for a specific aluminum rod. The tolerance level for the rod is between 80 to 80.8 centimeter. The company has discovered that the mean length of the company's rod is 8.2 centimeter and the standard deviation is 0.05. Does the company have a capable process? Is their manufacturing process within the specification provided by the client? So we have to answer this question. You can see that here, this is the mu, the process mu, and this is the standard deviation of the process, and this is the customer specification limit. Look at this. This is the lower specification limit, and this is the upper specification limit. So we have to see whether our process is capable and whether the process is within customer specification limit, and then we can also later see that the process is centered or not. Let's start. So now let's just continue solving the problem. So we can calculate the CP. It's pretty simple. Let's see. And so here, as you can see, the upper specification limit is 80.7. This is the customer specific 80.8. Sorry. Customer specification limit and lower specification limit is 80, and we will multiply. This is the 6, and the sigma level here for the process is 0.05. Okay, so the CP would be or 2.67. So what can we conclude from this number? Remember, whenever you find a CP greater than 1, you know that the process is capable in that case. So here the CP is greater than 1, so the process is well capable of meeting the customer needs. A process CP of less than 1 will never be capable of meeting customer needs. So we can see here in this case, the manufacturing plant has a capable process of meeting customer needs. But is it within customer specification limit? That's what we have to look into. See, CP, as I mentioned, will only give you the ratio between the customer specification width and the process width. It will never let you know whether the process is within customer specification limit. Let me explain it with a diagram again. Let me go back to PowerPoint slide at this point. And here you can see that this is a process. This process here is represented by the curve, and you can see the process is right where and within the customer specification limit. So width of the process and the width of the customer specification limit are same. And in this case, we can say the process is capable. Is the process is within the customer specification limit? Yes, it is within the customer specification limit too. But let's look into the next one, next curve, the curve below here. Here you can see the width of the process and the width of the customer specification limit is same, but the process is shifted toward the left somewhat. And from this we can conclude, though the process is capable, the process is not within customer specification limit, so it will fail to meet the customer needs. So how do we calculate this part to check whether the process is within customer specification limit or not? And this is where CPK will come into play. So let's get back to the CPK equation. So now let's calculate CPK, and you can see CPK is the minimum of these two equations in the middle. So let's calculate these two equations. One is upper specification limit here is 80.8, and the mu of the process is 80.2, and our sigma is here 0.05. So let's continue, and 80.2 here, lower specification limit is 80, and then 3 into 0.05. So it will be the minimum of the two of these equations. So let us calculate. Here, once we calculate, we'll get two numbers. One is 4 for this part, and then 1.33 for this one. So which one should we go with? Of course, the minimum one of the two, and that is 1.33. So CPK is 1.33. So what does it suggest? From this, we can reach a conclusion similar to CP. Uh, any value of CPK greater than 1 will let you know that the process is actually within customer specification limit too. Okay. Uh, CPK less than 1 will let you know that the process is not within customer specification limit. So in this case, the process is within customer specification limit. So the process is not only just capable, it is also within the customer specification limit. So this is another important number for us to come up with. Now, one thing you have to remember, CPK will never be more than CP, ever. Okay. It will be either equal to CP or it will be rather less than CP, but it will never be greater than CP. Now, the last questions for us to answer, whether the process is centered or not. How do you know whether the process is centered or not? In this case, what you have to look into is whether the CP value is equal to CPK or CPK is equal to CP. In either of the cases, if both the numbers are same, from that we can conclude the process is centered. If CP is 1.33 and CPK is also equal to 1.33, from this we could conclude the process is not only just capable or within customer specification limit, the process is also centered. So this is how you calculate CP, CPK value and answer the three important questions: whether the process is capable, process is within customer specification limit, and whether the process is centered. So that's what we had for this clip. I hope you'd be able to answer the questions that are attached to this clip. I wish you the very best. Thank you.